So today we are going to discuss about the topic fast Fourier transform. So this is one of the important topic in digital signal processing subject. So what is fast Fourier transform? Fast Fourier transform is a very popular algorithm which is used to compute discrete Fourier transform with minimum number of computations. In FFT, the time domain sequence x of n is converted to frequency domain components x of k. So by the help of this frequency domain representation, we can analyze the bandwidth of the given discrete time sequence x of n. So why we go for fast Fourier transform algorithm? So generally discrete Fourier transform is defined as x of k equal to summation n is equal to 0 to n minus 1 x of n exponential of minus j 2 pi kn by n for k is equal to 0 up to n minus 1. So in this mathematical representation, x of n is a given discrete time input sequence x of n. By applying this DFT formula, we find frequency component x of k for various values of k, which starts from 0 up to n minus 1. So in this DFT computations involve n squared complex multiplications and n into n minus 1 complex additions. For each k value, we have to perform n complex multiplications and n minus 1 complex additions. Since k value varies n time, so that we have to perform n into n complex multiplications and n into n minus 1 complex additions. So this much amount of computations involved in direct computation of DFT. That is why we go for fast Fourier transform algorithm. So what logic is used in fast Fourier transform algorithm? So there are two properties are involved in it. One is symmetry property, another one is periodicity property. By using those properties, we can reduce the computation level of the fast Fourier transform algorithm. So FFT is broadly classified into two types: decimation in time fast Fourier transform, and another one is decimation in frequency fast Fourier transform. So both algorithm, the computations are involved like multiplications and different additions. In decimation in time fast Fourier transform algorithm, the time domain sequence x of n is separated into smaller and smaller subsequences and combine the sequence until we reach the required DFT sequence. So in this algorithm, we use basic butterfly diagram. This basic butterfly diagram consists of two inputs A and B and its corresponding output X and Y. These two are DFT points. So according to the values present in the butterfly diagram, either +1 or -1, we can find the output or DFT points X and Y. And also in this computations, Tootle factor values are present, which is noted w n to the power k. The DFT point x can be find, which is equal to a plus w n to the power k into b, because the plus 1 value is present in the basic butterfly diagram. The DFT point y is equal to a minus w n to the power k into p. So in this basic butterfly diagram, minus 1 is involved. That is why two input signals are subtracted along with Tudel factor value. So next algorithm, decimation in frequency fast Fourier transform algorithm. So in this algorithm, frequency components are divided into smaller and smaller subsequences and combine the sequence until we reach the required DFT sequences. This algorithm also can be carried out by using basic butterfly diagram. This computation involves two inputs A and B and its corresponding output x and y. So here also Tudel factor value is involved in this computation level. The x DFT point can be done according to the plus 1 values present in the basic butterfly diagram. So x can be a plus b, then y equal to a minus b into Tudel factor value w n to the power k. So y can be calculated according to the value minus 1 present in the basic butterfly diagram. So following are computation levels are present in direct computation of DFT and as well as fast Fourier transform algorithm. In direct computation of DFT, so there are n squared multiplications and n into n minus 1 additions are involved in direct computation of DFT. In fast Fourier transform algorithm involves n by 2 log base 2 n multiplications and n into log base 2 n additions. So here we can see different number of samples value and its corresponding computations, either direct computation of DFT or fast Fourier transform algorithm. So in the algorithm may be decimation in time fast Fourier transform, or it may be decimation in frequency fast Fourier transform algorithm. So for example, we have 8 samples in a given discrete time sequence x of n. We can do the computation in discrete Fourier transform direct method, which involves 64 multiplications and 56 additions. At the same time, you look at fast Fourier transform algorithm, which involves 12 multiplications and 24 additions. So by using this algorithm, the computation levels are drastically reduced compared to direct computation of DFT. So that is why most of the digital signal processing applications we choose fast Fourier transform algorithm compared to direct computation of DFT method. Thank you.